I think gets 850, but something close to that 800, 830, 820, 780, 760, right? So the higher the score means, the better the person's credit worthiness, right? So now the point is, how do banks create that? If you see in the earlier models in the logistics regression, we created with the two like kind of uh, different kind of problems we analyzed, right? Whether to give pay insurance to a person or not, right? How much if I put this into a multiple linear regression, how much insurance premium, right? That person should give, right? Same thing if I look into the credit score in the, and this not only when you talk about credit score, card scoring, the model can be utilized across industry. It is not only for credit card, it can be utilized for fraud detection, it can be utilized for your insurance premium, how much premium, or whether we should give that person insurance or not, right? Same or little modification of that we can look into the employee performance or attrition, right? So this is the like beauty of the model or beauty of the concept, right? It is not only though it started as a credit card scoring model, like when people started using credit card, whether we'll give that person a credit card or not. Just imagine, because 50, 60 years back, when we do not have that much kind of information about a person, with a basic information about their location, job, gender, let's say age, right? How many years they have worked in a job, right? With those information, you have to allow a person a credit card, and you have to define how much limit you are able to give to that person, right? And same thing we are continuing for last 40 to 50 years. So basically, it shows the credit worthiness of an individual, right? Mostly banks. So this model have been modified a lot. Complex credit model that use information contained in application like salary, credit commitment, how many credit cards you have, how many times you have applied for a credit card, right? So that time, what used to happen, you will fill a form, right? Now, any of all your details, most of your details are available to the bank or any organization who are able to pay for that information, right? So the cutoff point, which is again essential point. So I'll say that okay, anybody who have a credit score or a CIBIL score less than 600 or 700, I'm not going to give them. So Amex has a very high eligibility, right? So if they say that if you have a below, let's say 750 or 780, they will not give you a credit card, right? So this is where you will be able to get this score, right? So this is a very simplistic scorecard, and at the end we are going to create something like this. So just imagine like 30 years or 40 years back, right? The front end employee, how he will decide, a bank employee, once you have put that application, based on this information, he has to decide whether that person has a good credit worthiness or not. So if I am able to give this kind of a checklist, right? So this document I give a printout, and somebody, let's say some person who is 35-year-old, annual income is around $38,000, and he has in own home, right? Now what will happen to that front end bank employee who is sitting in the bank? So we'll go through this document, which is an internal document, and look into, okay, that person is 35-year-old, so age is between 32 to 37, so I'll assign him 210 points. Income is $38,000, so he is somewhere between here 35 to 42,000. I'll give 225 points. Then home, yes, he has that person is own home, so 225. So total point is 660, and from the management, from the bank, right, or the credit card institution, they have set up a score of 600, right? So if that person is above that limit, then we are going to provide him a credit card or provide her a credit card, right? Obviously, right now, if you see in today's world, already your CIBIL score or the credit score is available with the bank. So that's why within the few seconds they're able to give you a loan or a credit card or whatever you are applying for, right? But so that's why I told this model. But even then, when that CIBIL or agency is calculating your score, right? So they'll be utilizing something similar to this kind of model, right? Where they have all the details, right? So once they input your or key in your details about your age, salary, all those information, at the end they'll be able to find out your credit score, right? So this is again like I said, there are different formulas. This is one set of formula just to show you I have taken from internet. I think that was one in article, but it is not that okay. All the credit score models use this same formula, right? Just to give an example of what kind of how do they calculate this kind of scores, right? So score I means so just imagine like let's say for a person I have around 20 or 30 variables I have collected data. Age is one variable, income is another variable, maybe gender is another variable, right? And this is where kind of like I was telling about easily interpretable by layperson, right? I'm not sure whether it is still in the Indian scenario how much stringent we are in, like kind of whether there is any kind of law which has been passed, or at least are there certain regulations that okay banks have to go through this kind of explainability of the model. But at least in USA and Europe, they go by this Basel Accord, where whenever they are doing this classification, right, allowing somebody loan or giving somebody credit card or not. Just a moment, I have a call from PGP office. Sorry, like I just have to like kind of go out for 5 minutes because there is an exam going on and some students have doubt. So your juniors have started giving offline exams, so many doubts. I'll just come within 5 minutes. So I'm keeping myself on mute and stopping the video. I'll join within 5 minutes. Okay. Sorry for that.
Yes, sir.
Okay, sir.
Sorry for that. They had some unnecessary doubt. Am I audible? Hello.
Yes, sir.
Yeah. So this is basically kind of a one kind of a formula. I'll show you what is this and how do they calculate. So score I means like score for the variable. Let's say I'm calculating the for the variable age, right? So this beta is basically the so again it the model uses most of the times logistics regression whether this person is a credit worthy one or zero. Based on that, the regression model which will be the coefficient for let's say age, right? That is the coefficient value. Then this is something interesting. Weight of evidence. This will discuss for that category or for that variable. Plus alpha is again a like kind of a logistics regression. What is your intercept or a constant value divided by number of variables, number of independent variables multiplied by factor. Factor is PDO, point to double the odds. That again I'll show you what is that. Divided by logarithm of 2, natural logarithm of 2 plus offset. Offset is basically target score minus this factor. Again, this formula is given. So again, not to remember the formula, like I said, this is not the only formula which is utilized, but just to show that how it is calculated. So if let's say I have a target score of 600, so I want to see that okay, if somebody is above 600, then only I'll give that person a credit card or a bank loan or a insurance, right? And below that I'll not give, right? So in that case, what will be my offset? 600 minus whatever my factor, then point to like kind of double the odds. Imagine in this scenario, if somebody has a credit score of 600, right? And somebody has who has a credit score of 620, difference of 20 points or difference of 50 points. Let's say somebody has a credit score of 600 and somebody has a credit score of 650, right? And when I say that 50 points is the point and I put that limit is to double the odds. What does it mean? So what actually we are trying to create here? We are trying to, the score is nothing but represent the credit worthiness of a person, how good that person in managing the finances so that he can or she can pay back the money, right? So when I say 50 is my point to double the odds, that means his credit worthiness will be almost doubling if there is a change of 50 score point of 50 or score point of 75 or score point of 100. So that is something I have to define. So I'm trying to tell the model, create a model in such a way that if a person's, if an individual's, let's say these points or the scores increases by 50 points or 75 points, his odds in the sense of, in this case, it is good, right? So that is basically being a better credit worthy person will double, right? So this is what means by the point for doubling the odds, PDU, right? Then what is what we have not discussed? Weight of evidence, right? Weight of evidence we'll discuss, and that is we'll discuss something called information value, right? But at least you get a glimpse that okay, how a bank or organization or CIBIL actually does a credit score for our case, right? So if I have taken a personal loan and I have not given certain EMIs, or let's say I have a credit card and I have defaulted in 2 or 3 payments. So my credit card score actually reducing, right? So obviously they'll be using a little like kind of a complex version of this formula, but this is how generally they calculate our credit score, right? I'll show you actually in the SAS also, right? But is there any doubt on this? Any questions, any doubt on this? Then obviously if I'm taking 10 variables or 20 variables, total score will be like in this case, I have taken 3 variables, age, income, and home. For each individual variable, I'm calculating the score, then I'm adding them up. That will be the total score for that person, right? So to understanding total score of a person, first I have to identify, okay, which are the 5 variables or 6 variables or 10 variables, right? I should consider to find a credit worthiness of a person, right? So this is where your weight of evidence or WE comes into picture. Basically, imagine a scenario, right? Obviously, in today's world, we have computers, laptops, and higher processing power, I can create a model and it will not within few milliseconds or even not that. If I input all the details, it will be able to calculate your credit score, right? But if you have a continuous data, if I take age in a continuous, income in a continuous, so there will be different people. Somebody in a 22 age group earning 10 lakhs or 15 lakhs, somebody who is 45-year-old earning 5 lakhs money, right? Annual income, right? So there will be a lot of permutation and combinations, right? So when we are continuous variables and I'm trying to calculate credit score, right? At least in today's world, it is easier because no matter how many variables you have, you just put into the model, it will be easy to calculate, right? 40 years or 50 years back when this system started, all right, they started creating a very simpler version, right? So rather than creating for or having this score for each individual, each permutation combination, right? Think about in this way, 20 to 30 age group. If I take all the people in this world, there will be people with zero income, there will be people with millions of income, right? So for which person I'll be giving a what will be credit score in that particular person, right? So this is where they started trying to discretize your continuous variable rather than looking into continuous number as a fixed numbers. They started putting into groups. So how it benefits us, so rather than like kind of it becomes easier for the banks or the credit card institutions to kind of create a offer model, right? It will be very impossible to create different offers, different advertisement for a 20 age group which is in a high end, like kind of a higher income, 20 age group with lower income, or 20 age group who is in a metro, who is in rural market, right? So this is where if I start to create these groups like we do in clustering also, right? So let's say I have people who are my bank customers with the age group of 20 to 72, 75, right? Rather than looking into those individual points, I try to create groups 20 to 30, 30 to 50, 30 to 40, 40 to 50, like that group. And I try to look into that group as a data point, right? It becomes easier for us to, so it is not that it cannot be created. Credit score cannot be created in other way around, but it becomes easier for our explanation, right? Okay, we are looking into this age group, right? Same thing like you can talk about the locations, right? In New York or in USA, there are some locations which is very kind of belong to poor neighborhood, like kind of very low income capacity, right? So rather than just targeting that, okay, I'll not give that loan to that location. So because again, like there will be rules or regulations which will forbid me to do those kind of model. So I aggregate some locations and try to look into a group of locations. Let's say Manhattan is one section, New Jersey is another section, like that, right? So it becomes little easier to look into at a from a you can talk it as a bird's eye view or a 35,000 feet above ground, rather than looking into very granular details. Somebody who is 35-year-old who is earning 10,000 or $50,000, right? So this is where in this basically the credit score model, we try to aggregate our continuous data, and how that is being done. That is where your weight of evidence. If you remember, we in the decision tree we discussed something called entropy Gini coefficient. It is again similar to that. We calculate something called information value, right? So it is very simple. Weight of evidence is logarithmic of distribution of goods or distribution of bad, right? So what do you mean by goods? Basically, we're looking at, because it is a credit score, right? Whether that person is credit worthy or not, right? So let us try to understand one example. Let's say I have different customers at different age groups, different ages, right? So I create 5 age groups, or let's say 3 age groups: 20 to 40, 40 to 60, 60 to 80, right? So in each age group, let's say 20 to 40, I'll find out what is my distribution of goods. Let's say in 20 to 40, it is 60% are good customers, right? Who will not default in the loan or who are very credit worthy. 40 are bad customers, right? So what will my the worth of evidence? Logarithm of zero point 0.6 divided by zero point 0.4. Distribution of good customers divided by distribution of bad customers. Plus, then I'm trying to find out what is that 40 to 60. Let's say that is 75-25. So basically 3 is to 1, right? Logarithmic of 3. Then above 60, let's say that is 80-20, the logarithm of 4. So by taking this variable and creating 3 groups, my weight of evidence will be sum up all these, right? Logarithmic of in that particular group, what is the distribution of good customers divided by distribution of bad customers, right? So this is how the calculation happens. So the idea is by using this formula, by using this technique of weight of evidence, am I able to segregate, right? I'm able to segregate between my good customers or bad customers. If my weight of evidence is higher, positive and higher, that means I'm able to segregate my groups properly. If my weight of evidence is negative or lower, right, that means I'm not able to segregate my groups properly, right? Negative values indicate that a particular grouping is isolating a higher proportion of bad applicants than good applicants, because my target is to isolate good applicants, to find out who are the good applicants, not that okay isolate. If my target is to like fraud detection, right, then it would have been distribution of bad divided by distribution of goods, right? Remember what you are trying to find out in a credit score model. I'm trying to find out who are credit worthy. My idea or my aim is to find out who are credit worthy, right? So it is a measure of difference between the proportion of goods and bads in each attribute, right? Each variable, under each variable, you will have at different labels, right? Let's say in age group, if I create 3 labels, 20 to 40, 40 to 60, 60 to 80, right? The odds of a person with the attribute being good or bad and negative W values are worse than in a sense that applicants. So basically, like if it is a negative value, that means I'm not sure about that group, right? So there are a lot of bad applicants, or the ratio is not like kind of uh, giving a good credit score, right? Then, so this formula is nothing but logarithm of distribution of good, distribution of bad. Again, percentage distribution. So if I again calculate for 20 to 40 age group, my ratio is 60% is good applicants, 40% is bad applicants. My information value for that will be 0.6, that is my distribution of good customers, minus 0.4, that is my distribution of bad customers. 0.6 minus 0.4 is 0.2, then logarithmic of 0.6 divided by 0.4, that is 1.5. So 0.2 multiplied by logarithm log of natural logarithm of 1.5, right? So again, for 40 to 60 age group, what is that information value? 60 to 80 age group, what is that information value, right? So by finding that information value, remember why we are doing this. In the like when we started this credit score model, let's say we have 30 variables or 50 variables, 50 different data, like not data points, 50 different information available about the customers. Now I'm trying to find out of those 50, 60 variables, which are the top 10 or top 8 variables which will help me to build a good credit score model. So for whichever variable information value is greater than, let's say, 0.1, right? That is a good variable for my model that I should consider in my credit score model. So all of what the weight of evidence we are calculating or information value is we are calculating, just to find out that out of all the variables, like in your regression, what is your that coefficient that you calculate your p-value, right? A t statistic, then p-value. If p-value is less than 0.05, it is a significant like kind of variable, right? Same thing here. What we are trying to find out, if the information value of that variable is greater than 0.1, then this is a good variable to consider for my credit score model, right? Obviously, if it is greater than 0.5, it is very kind of rare it will happen. So you have to look into whether you have collected data properly or not, right? So ideally, something above 0.3 is a good number. 0.1 is the cutoff. So anything 0.1 to 0.3 is good. 0.3 to 0.5 is excellent. Above 0.5, like we do it in a like kind of, if you're getting R square value very high, rather than being happy, you have to look into whether there is something very spurious about your data points, right? So this part anyhow I'll show in kind of SAS rather than going through here. So please open SAS Enterprise Miner. We are going to use a existing data set. Just let me open this. Just a moment. So again, we'll be using existing data set in SAS Enterprise Miner. Okay, so I've just opened and created a new project. So click on SAS Enterprise Miner. So I've given the name that CSC 18 March uh, credit score credit scorecard 18 March what we're creating. So I'll go to data sources, create data source, SAS table, browse. Again, where we got this market basket data, right? So in the same library, SAMP SIO, we'll go to something called credit score accepts. Okay. So I went to this library called sample data file which is available. Then I selected this file called credit score accepts, right? CS underscore accepts. Click on next, next, advance, next. So just let me put the label. So this is the information about customers. Around 3,000 customers are there. We have this information about the customers, right? Number of children, credit cards, requested cash. So this is something easy like a debit card, right? The electronic card in Europe. So this is known as EC electronic card. So salary, yeah, what happened? So so these are the information which is available. So what you have to do here, if you see, there will be something called. So this is a good customer or not, right? Credit toward the customer or not, right? So this is what we'll change it to a target, right? So this is our target variable, right, which is already given. So whether the customer is a good or bad, in other way, whether it is a credit worthy or not, right? And then what else? Age. So frequency here again, it is basically count data. You can keep it like that, or you can put it as frequency, right? Number of times that person has kind of applied for a credit card or not, right? So this shows that because if previously he has rejected or number of times he has attempted, it will be taken as little different than other variables, right? So again, like some variable you can reject also. See telephone, you know that telephone number whether you will consider or not. So that is something again. So this is you can keep it or reject it. Uh, this is where your business intelligence will come into picture, right? Title, title of a person, which is again a very sensitive thing, right? In today's world, when people identify themselves with a different gender identity, right? If you consider title is a factor, title as a factor for your whatever providing credit card or not, right? So that is something again you have to look into, right? So in my case, I'm rejecting. You can look into not rejecting also, right? uh, like this you can look into different variables and see that whether actually so it becomes easier, right? If you from the beginning itself you know that you are no way going to use those kind of variables, why to again, even if it is giving good value, right, you cannot use this in your model, right? So you put this, put next. Yeah, what up? Yes, just a moment. So in the decision processing, you put next. Sorry. So okay, decision processing. No, sorry. So we have 28 columns. Rows is 3000. That means 3000 customer data. Do you use to use a create a sample data set? No. Raw data here. So remember only what we have studied so far, only in one case in market basket data, we put transaction data because this is where we are interested, those whatever values or whatever transactions has happened, how many times it has been repeated, right? Otherwise, everywhere using raw data, right? Next finish.
Sir, I have a question.
Yes, yes. Yes, Apurva.
Sir, over there, yes, sir, there are three parameters given. One is salary plus EC card, and one is income. So we're having three salaries. So will it not affect the result?
Okay, just let me the variables. Okay.
So salary, I understand. I don't know what is EC card.
EC card is basically a debit card. Like in Europe or Germany, mostly there is something called electronic cash or EC card. So, like your ATM, in our case, it is a ATM or a debit card. So, what you said?
So, sir, why are we taking three times? So one is salary, one is salary plus EC and income. So name is INC. INC1
salary.
and
Okay,
income.
INC salary for EC card. Okay, this is basically you have a salaried account, right? Whether in that bank, whether that person has a salaried account, this person salaried account along with your kind of a debit card or not, then this is actually your income. So if you see this is income is interval, right? So this
Yes,
is
sir.
in dollars, right? So this is like whether that person has yes or no, nominal, right? Or what kind of label there, right? We'll look into that variables. What is
Okay,
like
sir.
so if you see these are number of labels, right? How many different kind of cards or they have here only three labels, right? So
Yes,
whether
sir.
that person has a salary account or not, right? So these are basically categorical variable. This is actually interval. So this, if you see, this is maximum minimum. This is the salary actual income. Okay.
Yes, sir.
Okay. Then what else? So this is somewhere like again, like it is good to like time at address. What actually it means, I actually also do not know. Time at job. This is which is very important, and you will see that that will come in our kind of this final model. Time at job means how many months or how many years that person has worked in that company, right? Time at address, I think how many years you have duration of stay in a location, particular location, particular city, right? Type of vehicle, credit cards, requested cash. So this I
Sir, we
hope this,
already
yeah.
have EC card holders here. So EC
Where is
card
this?
also. Yes, sir.
Here,
DIV, below
EC card
DIV.
holder. So
Yes,
these
sir.
basically yes or no, that person has a EC card or not. So yes, this is shows. This actually you have to look into what it shows. What are those six levels? This if you see EC card, whether that person has a EC card or not. So this, if you are taking this salary plus EC card, I think you can keep it as rejected either of this. This actually should be good. Number of finished loans. This is basically how many loans you have like completed. Number of running loans. Location of credit bureau. This is something I don't think this is in India. Something which is maybe useful in Europe or USA. Number of my bank loans. Number in household. So again, this is also collected in nominal. Ideally, it should be interval. Number of my bank loans also how it has been taken. So three. Number of levels is three. Persons in a household ideally like though it cannot be infinite, it should be a continuous variable. Type of business, profession, region, residence type, status, telephone. Telephone I have already rejected. Title also I have rejected. Title is what? Title is binary is given. time at second it is interval, number of years. So this I think hopefully it is in the months. Standard deviation 180, mean is 119 months. Time at job. This is, yes, so this is in months, not in years. 124, 10 years is, mean is around 6.5 years around. So I think hope I have covered all this. So this actually I'm also not sure how they take it credit bureau risk class, right? And how they are taking, how many levels are there? 3.
Sir, is region also an important factor?
Which one?
So region, there it was
Region.
given large region. Yes, sir.
Actually we should not, like I said, something in India I don't see like banks will look into those kind of legalities. Like I said, like I kept that example, right? In USA, mostly New York or New Jersey or Chicago, there are few areas which is very kind of mostly black people stay there, right? So if a bank is using this kind of model and saying that, okay, I'll not give, their credit score is linked to their region, right? Legally, they're not allowed to do that, right? So this is where you have to define your region. How do you define your region, right? So you cannot define your region based on the kind of population living there, right? You have to say that, okay, I've taken the radius of a state or the already geographically segregated region, right? Let's say in India, I have 30 states, 29 states. I'll say that, okay, that is a region. So that is already defined, right? But if I say that, okay, in Odisha or in, let's say in India, these are the states where these kind of population or poverty groups are staying. So this is where the explainability has to come in your model, how you have defined your region, right? If it is a geographically kind of identified regions, it's still okay, right? Because you are not creating on your own region. But if I say based on certain kind of poverty, caste, religion, I'm creating my regions, so that will be where the problem will happen. So was that your question, whether region is a good variable or not?
Yes, sir. Yes, sir.
uh, it might be if it is kind of a surrogate to certain kind of, let's say in India, if I take state as my like kind of variable, certain states with will have obviously more income group, more average income than other states. In that case, it might be a good predictor also of a credit score. But ideally, legally, whether we should take it or not, that is again challenging, right? Like I
So
said,
population will be a better measure, I think, in case of region.
uh, no, actually, you are looking into like think about in this way, whether you will give a card to a like again not getting into the model part, whether somebody who is from a tier one, let's say metro city, he is asking for a credit card, and from village, right?
Yes,
Whom do
sir.
you give a credit card without any other information available, right? Generally, our intention without any other information available, maybe that person is from metro. Most probably that person will be salaried or will be little bit average, more than average income. So that is a ideal bet or a good bet to give a credit card. But it is not always true. So there are people in village, like kind of farmers or villagers in Haryana and Punjab. So they are much more like kind of net worth than any kind of person in a metro city, right? So this is where like you have to take up a lot of variables. Whether region is a good variable or not, depending upon like past experience creating model, you have to see. Right? In some cases, it might not be. So if it is not, obviously, model is not going to choose you, like kind of not select in your final version.
Yes, sir. Had it been rural or urban, that would have made a
Yeah.
better
So that
impact.
that is how like kind of ideally it should be, right? Uh,
Yes.
Not on the basis of kind of here how they have done it. Just today is lot of disturbances are happening. Okay, so this is my file. I'll go and create a what did I do? Okay, create a diagram CSC 18 March. Okay, so I'll just put this here, data file. What I have to change here? Nothing here. 3000 data points. Then I'll go to sample data, create data partition. So let us say 70, 30, 0. What else? Yeah. So if you see here, there is something called credit scoring, right? So click here. There will be something called interactive grouping, right? Here, it is the first step where we are finding out which are the variables which are kind of most important for finding our credit score, right? So this is interactive grouping. So select this, log into this. Okay. So here, if you drag down, so there is something called optimal criterion. So there are different techniques of creating grouping. Generally, because we are creating a general linear model, which is kind of logistics regression is a part of generalized linear model. We are believing that our independent variables are linearly linked to it is in a generalized linear form to a dependent variable, right? So this is where generally we use monotonic event rate. Monotonic event rate is something like you remember what we limit theorem or the maxima minima, right? So if one variable is increasing, the other variable monotonically increasing, right? So we believe that, let's say, age, right? With increase in age, credit worthiness is increasing, right? Or with your increase in your age, credit worthiness is decreasing. So linearly related, with your increase in your age, either it is kind of uh, single. Monotonically means it is moving in the same direction. Monotonous, right? It is moving in the same direction, right? So this is how we are defining, because most of the times when we are using a generalized linear model, which is again in our cases is a logistics regression, good or bad, whether somebody is a credit worthy or not credit worthy, right? So this is when we use something called monotonic event rate to find out this weight of evidence, right? uh, what else? So information value cutoff, like in your case, like this slide I was showing, right? 0.1 greater than 0.1 is weak predictor, 0.1 to 0.3. 0.3 is a strong predictor, greater than 0.3 is strong predictor, right? So this again you can keep it as 0.1, because at least if it is greater than 0.1, it shows that that variable has certain value, right? Certain value in providing information for your credit score, right? So that is the only thing what we wanted to change. Binning method is quantile. So different quantiles it will put. Binary transformative method. Okay. So let me run this and I'll show you how it is being calculated. So we did two things only. We um, got a file which is already there in the SAMP ISO library, partition the data. Then we went to this credit scoring, brought this interactive grouping, right? So interactive grouping is basically, like I said, we're trying to create groups out of continuous variables, right? Age rather than 20 to 72. Continuous variable, we try to create groups. Income, similarly from minimum to maximum, we'll try to create different groups with which we'll be able to use or create our credit score, right? So that is the like requirement or the like kind of use of creating this interactive grouping, right? How it is created? So the formula which I showed you, right? Information value, distribution of good minus distribution of bad multiplied by weight of evidence. Weight of evidence is logarithmic of distribution of good divided by distribution of bad, right? So results will be there. So let me just show you the results first, then just a moment. Yeah. So if you see, this is how it shows. INC1 Do you remember what was that INC one? I remember INC. I think it was income, status, TM job,
So INC was, yes, a salary plus EC that
EC.
was
Okay,
given.
whether that person has a salary
Cards.
account and
Yes,
EC
sir.
card, right? The status. So these are the variables which has highest input. So if you see 0.3 above 0.3, anything above 0.3 is a very good strong predictor or a strong like variable for your credit like kind of this model, right? Age. So the age is one of the variable which is anyhow you have to take. Then INC1, INC status, TM job. These are the other variables, right? So this is what your model is giving, right? But let's say your management says, so now if you see how it has created your age group from, let me see. Just. Okay, so this is the information value of different variables. So age followed by salary for DC clerk, salary, status, time at job, number of credit cards. So these are the other variables. What I was searching for, I'm not find. Okay, I'll show you there. So let me go back to the this original SAS enterprise miner where you calculated. So if you click here, interactive grouping, right? Like we used to do it for a decision tree. If you click here, so which is prune decision tree, we did that time, right? So this is where, let's say if I click in these groupings, okay. So now you see that how the groups has been created, right? So age 22 to 28. So okay, age less than 22 in group 1. So how many groups it has created? Actually, it has created 5 groups, right? And your information value is 0.353, right? So your management says no, 5 groups is kind of this group parameter which you have taken 5 groups is too much. You create 3 age groups, right? So if that is the criteria from your bank management, they say no, 5 age groups is too big, right? So just create only 3 age groups, right? So what we'll do? So anything below, let's say, till how much? Age 22. Okay, age 22 less than 22, where there will be very few customers. 24, 28, 28, 29, up to 31, right? So I can merge bins. So this is one, then 31 to 45, let's say. This is another, then this is, let's say, another. Okay, then missing value I'm putting in the 47 age group, right? So there is basically 3 age groups being created, right? Why it is one is upward. So if you see, earlier I have 5 groups, right? Which actually model told that, okay, create 5 groups, it is going to give you good information value, right? So I told no, my management says only 3 groups to be created. So I created 3 groups. Anyone above less than 31, so they will be have one score. 31 to 44 another score. Score for what? Score for their age, right? Above 44 there will be one score, right, for the age, right? Again for different variables like that we have to find. So if you see your information value actually reducing, right? Earlier it was 0.353, if you see it is coming down to 0.312, right? So this is where you have to decide whether to go with, because you are getting less information from this age group variable, right? Whether to go with whatever your management said, or you will say that no, let us try to stick with whatever 5 age groups which our model showed us, right? Similarly, if I look into another variable, let's say this time jobs. So this is where it has created how many? Again, 5 groups, right? You have to look into whether this, you can look into the different different kind of explains criteria, less than 6 months, 6 to 9, 9 to 15, 15 to 18 like this, or you want to keep it less number of groups, less than 2 years one group, 2 to 4 years another group, above 4 years another group, right? So here if you see the information value is right now 0.187. So if I try to do that, let me see whether it is improving or reducing. So what I say now, I say less than 24 months is one group, 24 to 48 another group. Sorry. 24 to 48. 24 to 48, 45 to 66, 66 to 96. Anybody having 120 means 10 years, right? Okay. So I created 4 age groups. So again, it has slightly reduced, right? New information value is 0.175. Generally, what happens if you reduce your number of groups, your information value generally reduces. But again, you have to look into how interpretable, because in that case, less than 6 months, 6 to 9 months, 9 to 15 months, right? You are creating lot many complexity, right? So whether this will be better than that, right? So this again has to come from your business insights. Sometimes you have to say that no, we'll go by the 5 groups or 4 groups or 3 groups, right? So is this clear, like why we are doing this and how it is going to be helpful? Basically now we are creating different scores or different kind of groups which will be helpful for us to find out a score for a particular individual. How to do that, I'll show you in the next slide. So I'm not going to save this, I'll keep it whatever original was there. Then I'll go to this again, credit scoring, scorecard, drag this. Okay. So this is where this, what is your scorecard points, right? So this is what you'll say that, okay, I want to keep close to 600, right? Anybody above 600, that will be my cutoff score, right? Again, this is our assumption. We'll try to find out what is our cutoff score, right? Then point to double the odds, like at what interval, if I say that, okay, 50 points increase or 20 points increase, the odds of that person being more credit toward these doubling, right? So let me keep it as 20 if it is there. Okay, analysis of variable, we are taking this what we calculated here, weight of evidence, right? Or you can create separate groups for it, right? Like we will say that no, take these groups, age group, you will create a separate group, income group, you will create a separate group based on your business insight, right? So that also, right, you'll not go and look into the WOE value, weight of evidence value, will create group of your own, right? In our case, anyhow, it is weight of evidence what we have calculated, right? So if you just run it, okay, here one thing we have to do, we have to put a detail so that we can know that, okay, let me run this again. So we want to say that for each group, what is the like kind of like in the first I showed you a scorecard, right? We want to get a scorecard like that. Okay, let me share the results.
Sir, here also false positive and true positive is 0.
So in this particular case,
Yes, sir. Sir, output is coming 0.
just a moment. Here also it is coming for both for validation and training, which is not good. So some parameters we have to change. Okay, so let me just show you the result. Okay, so most important thing out of this, let us try to see that first. If you go to your model, so there will be something called scorecard. So which is actually we want to see, and yeah. So this is what I showed you in the beginning, right? So this is like template which will be utilized for your kind of calculation of your credit scores. Let's say somebody who is below age 22, he will be assigned a scorecard point of 52. Somebody, whether that person has credit card, which kind of credit card, if is American Express, no credit card, Visa, missing value, unknown value, he's getting a number of 70. If he is this kind of credit card, he is getting a value of 83, right? So like this for different variables, time in the job less than 15 months, he is getting a score of 64. So if you see here, the more the time he is staying in the job, he is getting more number of kind of more points, right? Status. So this is what actually I'm not clear what TUEG means, right? Number of household persons in the household, less than two, better, more than two, like let's say uh, having children of more number of persons, actually your credit worthiness is decreasing because score is actually decreasing, right? So how to use this? If you add this up, right, for a person, what is your credit card like score, that you will be able to get like we did in the beginning, right? So this is a template. If you put in a front end model, like your bank executives, your front end employees can use anytime some application comes. So nowadays it is almost automated, right? So somebody wants to apply for a credit card, he'll automatically go and put his details, provide information, provide all the like kind of details which is the bank is asking. And in the back end, if you put this kind of logic, if this is the age limit, assign this score. If credit card, this kind of credit card, assign this score, and you add this up and say that okay, this is your total credit kind of worthiness or credit score. And if it is above certain limit, you'll say that whether that bank is going to give you a credit card or not, right? So this is how it is calculated, and how to know that what is that cutoff value, right? You go and find out this K and S plot. So go to the wherever is the maximum, right? So whichever cutoff score has the maximum statistics, K and statistics, right? So that will give you the cutoff score, right? In our case, I think it is 592, right? So because below that 0.319686. Here also I think same 0.319684. Okay, so this is 319686, right? So 588 or less than. I think that is the number 588. Only in the peaks it is. This is 584.307662. This is 319686. So this is 319684. Just slightly less. So this is giving around cutoff score is 588. So now you can go and say that anybody who is having, at least based on this model, above 588 eligible for a credit card from your or bank loan from your bank or a credit card from your bank, right? So using that scorecard, right, what we just shown. Then obviously the other parameters, leap, uh, which is basically kind of, if I just highlight this. So for the top, so generally leap, if you remember what we discussed, how your model is performing in comparison to base model, right? If I randomly assign credit cards, right, without using any kind of predictive model, how that model performs in comparison to what I've created here, right? So at least for the top 30-40%, depth is nothing but the first, that 40% of your top customers, right? Your model is actually performing a lot better than your base model. Base model means you do not have this predictive model. You randomly assign credit card to without any kind of this kind of predictive credit score model, right? So it is actually working in the first top 20%, at least minimum your lift is cumulative lift is 2.4. So it is outperforming your base model by 140%, right? Your cumulative lift is around 2.4, right? So this shows that okay, at least your model has certain value, right? One more thing generally we look into, like we said, the score improves, right? Empirical odds, right? So empirical odds in defaulting is actually reducing, right? The score whatever is improving, right? If you see here in both in your training model and validation model, as your score is improving from default 540 to 640, maximum around 640 will get, or less than 640, right? Your empirical odds of defaulting, right, is actually decreasing, which is good. So this is about your empirical odds. Then what else? Case statistics is we got 0.31986. So this is where we got a score of 584, right? So that was, so from here also you can see that what number you have to take. On under curve is 0.71. Again, this one thing what Apurva was told, I have to look into that, why that is. Again, both of them are becoming 0. Tells what is your information.
Sir, in the status that was given, status T. So status T is for terminated, U is for unclassified, E is for estimated, G is for good, and W is for excellent customers.
Okay, so that is basically bank they kind of identified like okay. So
yes, sir,
it is
they
basically
have some score.
okay.
For
So
that.
is it a continuous variable or a label?
No,
Like
sir, not. So I think it is
okay, labels
continuous,
means
sir.
yeah. No, it is a, you told those are only starters, right? T, U, E, and all those things. So that means it will be
So they
nominal.
have named it as, yes, sir. Like for example, W status is given to people who have a range between 600 to 750. Only those are the customers, they will get W score. Status.
Okay.
W status.
So that they have defined like that.
Yes, sir. It is defined over there.
Okay. So only problem is here it is coming as 0 both in your train and yeah, that's all. Okay, this I'll check, and that also I'll check for your decision tree also. I think it is we're getting the same issue. Somewhere we're doing some error. Okay, so that's all for today. And that's about your credit score model. Any last questions, doubt?
Sir, in the decision tree, sir, that you have given, sir, can I just manipulate the parameters that are given to
Yeah,
try
so you
and
can
see?
do that, but submit both the files, right? Because others have not changed the parameters, right? If you're finding
Yes, sir.
like changing the, mostly if you play with the leap size, right, you'll get a value. But last time, I think nobody has pointed the problem. Yeah, you can do that, but submit both the files. Submit the files, whatever I had given you those parameters. With that, even if it is coming as 0, and by
Yes, sir.
changing that leap size and other parameters, if you're getting a correct parameters, you can submit that also.
Okay, sir.
Okay. Okay. Chalo, take care. We'll see you next week. Next week, please prepare for your quiz. Bye bye.
Sir, I missed my 204.
Number 204. Okay. Anyone else?
Sir, will you do neural network? Or are we not going to
No,
do
we
it?
don't think we'll have time for that because we have a class, I guess. May first week I won't be available, and I think next class will be our last, right? So that will reach
sir.
out for any kind of doubts and quiz.
Okay, sir.
Okay. Chalo.
Thank you,
Take
sir.
care. Yeah. Bye bye.